Hello, RGL3000 students. Dr. Conway here for Lesson 4 on understanding data types in economic analysis. This would be a short lecture video because the slides are fairly straightforward and it's a technical question. But for those who might not have training in quantitative methods, we need to at least describe some key concepts. For those who have had training in this area, you can review the slides quickly and I'm sure grasp the subject matter in a fairly straightforward manner. Okay, so let's get started on going through this particular issue, particular lesson. We've already described how when you're doing empirical research in any kind of area, particularly in socioeconomics, there are three core issues that are involved. What is the issue or objective we're investigating? We've been through this before. What is the scope of the analysis? And as you recall, you need to determine the scope in order to be able to determine costs and benefits on constituencies out there. Costs and benefits, direct and indirect, intended and unintended, as we discussed last lesson. And that you need both the issue and the scope to be able to build a baseline. And of course, you need your baseline because your baseline is what you use for comparison in any economic analysis or socioeconomic analysis. The baseline is what you use for comparison on changes that occur because of in our case, because of the regulation that was put in place. We decided to manage a risk for cell phone use in cars. We bring in a regulation. What effect is it having relative to the baseline and numbers of accidents that were caused by cell phone users? Are the accident rates going down? Are the numbers of people found using cell phones in cars going down, etc.? All right. So these are just a reminder that these are very important. But getting into some basic concepts related to economic analysis or any social studies analysis or experimental analysis for that matter, you need to identify variables. What are variables? Variables are essentially a way of managing or identifying and measuring the factors that you expect to become subject to influence when you bring in a regulation. So one of the variables, for example, in the cell phone, one of the variables would be numbers of accidents that are occurring. Another variable would be number of arrests or number of fines. Another example might be whether the cell phone user is, running red lights or things like that, depending upon what's important for your study, what factors are important for your study. In other words, the factors that you are trying to influence by bringing in a regulation, those factors need to be measured some way, right? To determine whether the regulation is having the effect that we thought it was going to have. Is it reducing accidents? Is it reducing fine times? Is it reducing traffic light violations? Is it reducing whatever the case is that a factor that we consider to be an important aspect of risk that we're trying to manage with a regulation, or a factor of harm that we're trying to manage with a regulation? We have to find some way of measuring that so that we know whether our regulation is in fact having the desired effect. Okay? And we call them variables because the response to those factors may vary between various circumstances. For example, we may find that the cell phone law for the average user, brought down problems with cell phone use while driving a lot, but maybe it's not being as effective for construction workers who are driving around in vans, setting up meetings or whatever. Okay, so it depends. There are deviations or there are differences between how factors will be influenced by different subcategories of the population. All right, so we call them variables because the results against that factor can vary depending upon the circumstance, depending upon the people, depending upon the circumstances that these people find themselves in. Okay, so we call them variables. Okay, let's give a simple example of a fitness program. What will we be trying to measure as factors of our fitness program? Okay, in a fitness program, the baseline would be comprised of data on age, gender, starting body weight, fat percentage, okay, of the body, resting heart rate under a specified level of stress, cardiovascular stress, so on, would be a number of factors you would measure when the client came into your office because you're trying to establish a fitness baseline on factors that are important to define what fitness is. All right? And that becomes your baseline before you put them on their fitness program. It's the same thing with a regulation. What is the characteristics of the harm, the factors that are contributing to the harm that we want to regulate or that we want to influence through our regulation? We need to baseline what's happening today so we know once we bring in our regulation whether those actions have been effective to achieve the harm reduction we're seeking. So the factors needing to be measured in this simple research issue objective or example are age, gender, starting body weight, fat percentage of the body, resting heart rate under stress, specified level of cardiovascular stress, specified duration of cardiovascular stress, would be all the things that I would measure when you came into me as a trainer. Okay, I would look at to see where you are today, because any regime that I want to bring in, which for our purposes is a regulation, a regulatory regime, I want to know that I'm designing that regulation in such a way that it's having the desired effect on those baseline factors, which become variables because responses on them can vary. For example, if 3 people walked into my office and wanted to be in the same training program, they would each have likely different values on those factors, depending upon how well they reacted to the training program. The same thing applies to a regulation, okay? So we are seeking to measure those factors to determine whether we're having the desired change, okay? And because scores on these factors will change and vary on these factors, we call them variables, right? Variables, okay? Now, a variable refers to some specific characteristic of a subject that can assume one or more different values. That's how we define a variable. A value is essentially a score on a given variable. So of those 3 fitness clients, one would have this score. Oh boy, you reacted well to the training. This, maybe you're just a better athlete or you worked harder or whatever the case may be. Participant 2 would have a different score on that variable, and likely 3. It's very unusual if they would all have the same score on that variable, right? So we have different values on the same variables. Now that said, there are also different kinds of variables, right? And each kind of variable, portrays a different level of information, a different detail of information. For example, when we're dealing with some variables, you're simply asking, the respondent male or female, or you see them in your office, so you're checking obviously female or obviously male. All right, okay. So, or you can be asking what is in the income range, and people will have different values on the income range, and so on and so forth, right? And so each of them has an option, for variable values on that factor, and that's why we call them variables, right? An observation is an individual response to each variable, or an individual measure for each variable. So athlete 1, 2, and 3 each have their own observation on that variable. Athlete 1 had a better observation than athlete 2, and athlete 3 had a lesser observation, and so on, okay? So we call them, variables and observations on those variables, all right? All designed to measure the influence we're having on a factor, in our case, a factor contributing to a harm, all right? So, and one of the key rule that we have to remember when we're doing any form of socioeconomic analysis is there's a hierarchy of desired variables, the way we measure factors. There's a hierarchy that we like to see wherever possible. Why? Because that hierarchy portrays different valuable types of information, a different level of valuable types of information for analytical purposes. We would typically say that monetization is best, quantification is second best, and qualification is third best, okay? Monetization data is exactly as it sounds. Values on a variable that can be expressed as money. Why is that important? We've discussed this before. Is it because we're money-grabbing economists? No. It's because monetization is the only unit of measurement that we have that we can compare completely dissimilar subject matters across space and time. Okay, that allows us to do things with our analysis that we cannot do if we're doing simply quantification or qualification. Now, quantification is also numeric, so it can also be powerful, right? But it is not monetized. Values on a variable are values on a variable, right? A variable measures a factor for which values can vary. Okay, that's why we call it a variable, right? And in this case, we're expressing them in quantities, all right? And that can be very powerful, right? If I'm going to spend $100 million, how many girls can I influence to stay in school for longer periods of time? Okay, cost effectiveness analysis, right? Relies a lot on quantification. Monetization is essential for cost benefit analysis because we're comparing the value of costs and benefits, right? In cost effectiveness analysis, we're monetizing the cost but only quantifying the benefits. Then there's qualification, which is largely descriptive. Qualification always comes along with monetization and quantification because you're using qualitative description to explain the significance of the findings, of the numeric findings. But often many research papers are done purely with qualitative analysis, which is, a descriptive characterization of observations, right, rather than a numerical description of those observations, all right? So variables are in a study are designed to capture the data type that is needed to ensure that a variable makes the appropriate contribution to the study issue or objective. For example, there's no use talking about how many people were exposed to adverse effects to a pharmaceutical drug and saying in your research paper you say, well, there were a lot of them. Well, what is that? What is a lot? So obviously in those cases we're going to want to have at least quantification to be able to say that 7,346 people over the last 5 years during the licensing period for this pharmaceutical were exposed to particularly extreme adverse effects. Powerful message compared to there were a lot of them, right? And then if you wanted to go even further, well, what are the implications of that? What did this cost us? Then you have to go right to monetization. How would you do that? They had adverse effects. How do we know how much it costs? Well, there are ways of doing that, right? How many jobs, how many days of work that were lost, what it cost companies, what it cost the healthcare system. There are ways of monetizing that. But you can understand that when you're dealing with variables related to regulation, you're always seeking the highest level of data. You're seeking at least quantification, and often you're seeking monetization, okay? And monetization might be essential if the goal is to show cost differentials before and after. Okay, like the example I gave on sub-Saharan African pesticides, that was a monetization project using the cost of illness method, all right? Now, that didn't deal with the cost to ecosystems. That didn't deal with, because our scope and our baseline was purposefully reduced to something that we knew we could monetize, all right? In an acceptable way that people would buy into as seeing as credible. If we decided to start to monetize impacts on river ecosystems and fish and all kinds and historic sites and all that kind of stuff, the other areas where toxic pesticides can have a negative impact, we would have been bringing people into an area of methodological sophistication that they may not have understood, and therefore would undercut the credibility of our study, regardless of how good the study was. You understand? So we're always looking to quantify where possible and monetize ideally for a lot of these studies, except for in those cases where we purposefully want to adopt a cost-effectiveness study because we have a moral and ethical imperative with respect to the results of what it is we're investing in, okay? So, and you have to be very sensitive to the fact that an additional influence on the quality of information gathered in the study is not only issues of monetization, quantification, and qualification, but also this, what we call the scale of measurement, okay? The scale of measurement. And you have to have some exposure to that to understand what's going on, all right? So, and there's three classes of variables: nominal, ordinal, and interval variables, all right? And so let's talk about, there's also ratio scale, but we're not going to spend a lot of time in ratio scale because we're not dealing with the issue of absolute zero. But anyway, let's not focus too much on that. We're dealing with three classes of variables, and each of them can be important for a study, all right? But each of them has completely different uses because they embody different qualities of information. When we're dealing with a nominal variable, it's not hard to say what is a nominal variable. The word nominal, name. Okay, So, for example, a nominal variables in a study would be, gender, ethnicity, language, city of birth, favorite color, length of hair, color of hair, whatever the case may be, which would be data that you would use to basically metadata the database. In other words, there are this many females that responded. Or I may decide once I have the database that I'm only going to look at females for all the other variables in the study, or only going to look at males for all, or only going to look at French speakers for the whole study, or only going to look at people who were born and lived in cities within this jurisdiction. And so you would use this data to partition out the broader data set. These are called nominal variables because they simply name things. Why do we consider those to be largely metadata or organizing data? Because they don't contain a lot of other additional information of tremendous value. For example, we can't rank a John over a Bob. We can't rank a he over a she. We can't rank a English over French or Hindi or Mandarin. We can't rank, these things are not things we can rank with any kind of an empirical validation or validity. So we name, they're strictly names. They're simply ways if we can organize and identify an observation based on certain characteristics like male, female, language, or whatever the case may be, if those are important criteria for our study. Okay? And their demographic data are what I call metadata. It's very, very straightforward. Okay, I'm not going to get into the slides, you have them, but it's important for you to understand that. Now, ordinal variables are the next type. It contains additional information. Why does it contain additional information? Because relative to nominal variables, with ordinal variables, we can at least rank order the responses. Okay, with nominal, you can't rank order. Can't rank male, female higher, or red hair or blonde hair higher, or anything like that. But within ordinal variables, you can rank order. What we don't have with ordinal variables, though, is the exact increment between the rank order. For example, if I ask each of you what your income is, some of you, well, many of you would put some number lower than 20 to 39,000 because you're students. But let's just say you're off working, and some of you would go 20 to 39,000. Some would, hopefully not that, but some would go 40 to 59,000, 60 to 79,000, 80 to 99,000, and all of that. So I can say that the person that answered 80 to 99,000 is making more money than the person that checked 60 to 79,000. But there's a limitation in that data. I can rank order these people based on that, okay? But I can't tell you exactly the increment between these two cases, all right? Because that person that checked 60 to 79 may be making 63. The person that clicked 80 to 99 may be making 87. But we don't know that because we did not collect the data fine enough to be able to determine that increment. So you can see that rank ordering of ordinal variables can be powerful, and they might be necessary variables together because people might be reluctant to give you their exact income, but they would give you a range. People might be reluctant to say, I smoke cannabis 3 to 5 times a week, but they wouldn't be very comfortable saying that I smoke it exactly 5 times a week, or something like that. So in some cases, you have to use ordinal variables to be able to tease out the information you want. And then sometimes you don't have the precision of the data, or the data you're using from, you're not really sure that it's going to be that fine and that reliable, that we better reduce the error factor by just accepting that the best we can do with this data is create an ordinal variable. Because we don't want to pretend we have precision that we don't have. There can be numbers of different uses of ordinal variables where this is what you end up with. It's still better than having exclusively a nominal variable, but the ordinal variable, we can rank order, which can be powerful. It's not nearly as information intensive, okay, as an interval variable. All right. So interval variables are those variables where you can not only rank order, but you can tell the exact difference or increments between observations on a variable. Okay. For example, if you asked people to give me your income number on your T4, okay, and you don't have to give me your name, just give me your info number and your T4. Then I can actually say that there's a certain amount of people that made X numbers of dollars more than another group of people. All right, so actually or electrical bill. How much do you pay in electricity each month? Oh, I pay $123. Okay, and the other person pays $75. The other person pays, the small company pays $230, and so on. We can actually tell the exact increment of what these people have paid in their electricity bill, which we would constitute as an interval variable. It allows us not only to rank order, but know the exact increments between ranks. Now, we can create an interval variable into an ordinal variable when we release public information. Let's say we have an interval variable, but when we release the information to the public, we don't want it to be associated with names or confidential information. So sometimes we would take interval variables and make them into ordinal variables, which you can do in software packages and so on. But the point is wherever feasible, obviously you're trying to collect information in a way that allows the most value, most information to be derived from that variable and the way it's collected in terms of its scale of measurement. Okay, so often we're seeking to use interval variables, and ideally, as the previous matrix we talked about, monetization is best, quantification is second best, qualification is third best. Interval variables, that are monetized are even more powerful, right? This person made $78,700 last year. This person made $94,300 last year. I know exactly the difference in their income. Okay, that becomes a powerful tool if I'm trying to explain various factors. All right. So these are the different levels of measurement. So whenever we do a RIAS, we're seeking to, wherever possible, gather quantitative information because it's the most powerful scale of measurement, right? And wherever possible, we're trying to monetize that because if we're doing a cost-benefit analysis for a medium and high-impact regulation, that becomes a very important factor, okay, in being able to reach certain kinds of analytical conclusions, all right? So anyway, that's the type of thing that we need to be sensitive to. Now, wherever possible, when we're doing a RIAS, obviously, we want to have monetization wherever possible. Okay, now in some cases that's not going to be possible and we have to settle for quantification. But very rarely in a RIAS would we ever rely on qualification data beyond its essential role in developing the themes, the ideas, the conclusions, the analytical insights that come out of quantification and monetized data analysis. Okay, for example, you do a monetized data analysis saying that the benefits exceed the cost by this much. The data can tell you that, but the reader's going to need some explanation. Well, how did you deduce that, and how would that play out? And a lot of very valuable information goes into qualification. But when you're doing a socioeconomic analysis, whenever possible, you're seeking quantification or monetization because you can be more precise with your conclusions. Like I said, there were a lot of people that got sick from this. Okay, that helped me identify that there's likely a problem here, but I have no idea from that what the scale of the problem is. But if you tell me that 7,000 people got sick in this, I can go, whoa. Okay, 7,000 people got sick on this. How does that compare to the last time we had a problem with a different drug? Oh, the last time we had a problem with a different drug, we were alarmed when there was only 2,000 people that got sick. So this is a big problem. You see, the strength of that, just by going to quantification gave me a lot more information. Then if I go not only from quantification to monetization, I can say 7,000 people got sick from this. And the economic impacts of that were X. Again, another level of more powerful argument that can be made, okay? Because more information is embedded in that scale of measurement for those variables or those factors that contribute to a harm, all right? So go through these slides very carefully. We have our Zoom call on Wednesday at 4 o'clock, and so we'll have a chance to take up any questions related to this and any questions related to part 1 of your RIASs, okay? Have a good day.